was all the stuff you did last week. So this is all revision stuff. Alright, so none of this was really that new. So in fact, we did these ones were like past examples. So can put it down. How do you do the first one? Looking at your formula sheet. On your formula sheet, it says b to the x equals y. Then it says the log of b y equals x. So log of y to the base of b equals x. So if we rearrange the first one, which is my b? 4. That's obviously in this form here, eh? So b at the top goes, that's 4. Which is my y? M. So that's going to be equals m. Which is my x? 6. So it's 4 to the power of 6 equals m. Get your calculator out, 4 to the power of 6. It'll tell you the answer is something along the lines of 4,096. Okay. You can check that out by pressing log of what? I can check that answer. That is sort of down here. Log of, if you chuck that into your calculator, log of 4096 divided by the log of 4, that should give you an answer of 6. Try that now if you have time with your calculators. So, the next ones, these were our log properties that we started to explore on Friday, which you're going to do a little bit more of today. When you are adding logs, what did you end up doing? So the answer to the first one would just be log 10. Log 10, because 2 times 5 is. Next one, log of, yeah, when you're subtracting, you divide, which is just 8 over 7. Leave it as a fraction, it's still a single log. Okay. The next one, log 16 plus 3 log 2. When you've got 3 log 2, what's that the same as? 2 to the power of 3, yeah. So this is the same as log of 16 plus the log of 2 to the power of 3. 2 to the power of 3 is 8. And because it's addition, you're going to multiply those together. So that's actually 8. The log of 16 plus the log of 8 is the log of 128. 16 times 8. Okay, we're happy with 128. All right. Any questions on that one? Okay, that one there. This one here is the only sort of one that's on your formula sheet, which is what I'm going to print out for you now. But you need to know that when you're adding logs, you're multiplying the numbers. When you're subtracting them, you're dividing the numbers. The next one, log x minus 2 log y plus 3 log 2. Just do one at a time. Yep. Log of, so what's 2 log y would be y squared. So I'm just going to do it once and for all. So I'm going to have a x and I'm going to have a y squared on the bottom. And then it's going to be times by log 2 to the power of 3, which is 8, isn't it? So it's just going to be 8x over y squared. Happy with where I got the 8 from? Happy why it's 8x? Okay. And the ones on the bottom, well, they're the same as the top ones, really. So this is x to the power of 2 is 16. So x is 4. Should it be plus and minus 4? Okay. Could be plus and minus 4 if we go down that route. Plus and minus 4. Let's check that. Let's just double check that. If we go, I want half of the class to do log of 16 divided by the log of 4. It's you guys. Other guys, other half, I want you to do the log of 16 divided by the log of negative 4. Okay? Check that. Log of 4 on the bottom, log of negative 4 on the bottom. What are those answers? 2? Bottom one? Math error. So this one here is a math error. Okay, so because you can't take the log of a negative number. Why can't you take the log of a negative number? Because something to the power of anything, like 3 to the power of x, is never going to give you a negative number, is it? It's going to give you really, really close to 0, but it's never going to go into 0. Think about the graphs of a log graph or an exponential graph. There is that asymptote, isn't there? Okay? So this one here does not exist. So it is actually only, there's only 4. Understanding that will get you an excellence. Okay? Understanding that will get you an excellence. So the next one, this is going to be x to the power of 4 is 81. So how do I solve that? X to the power of 4 is 81. The 4th root of 81. Make sure you can do the 4th root of 81. Your calculators now. The answer should be 3. Is it plus and minus 3 or is it just 3? Just 3. Solving for plus and minus 3 and then ruling out the negative is your excellence. Okay? Obviously not in that particular question, but it is an excellence question, excellence understanding. And the last one will be x cubed is 100. So x is the 3rd root of 100. Can you make sure, please, that we can get the 4th root and the 3rd root? If you can't do that, put your hand up now. You can't do the 4th root and the 3rd root. Can't do those. Right. So this is what we're going to start on with now, is trying to solve some of these equations. So now you've been able to manipulate them, okay, and we're going to try and solve some of these now. So at the start of this topic, we started answering questions where we had x was a base and we had x as an exponent. Okay, that's what we're going to start looking at today, is which ones do we use and when. Remember, when x was the base, you found the answer using like the square root, the 3rd root, the 4th root, what we call a method called the nth root of that, n being whatever the power was. And when x is the exponent, that's when you're going to have to use logs. Unless it's a nice, easy one that you know the answer to, like 4 to the power of x is 16. Okay? So this is what we're going to start doing now. So if I give you these questions here, which are on page 289, how would you do question 2? How would you evaluate that log, those logs there? How would you evaluate the log of base 2 of 8? Or more importantly down here, how would you do the log of base 7, 1? Log of 1, base 7. How would you do that in your calculator? It would be the log of 1 divided by log of 7. Okay. Where does it come from? It comes from your formula sheet. Yeah, on your formula sheet. That's the sort of. Actually, no, it is not on your formula sheet. It comes from the process that when you apply logs, that happens to end up there. I don't want to confuse many of you, But all you're going to do there is go the log of 1 divided by the log of whatever that base is. So the log of 8 divided by the log of 2. Okay, put into your calculator to get your answer. Okay. Question 1 though, how would we solve 3 to the power of n equals 12? Or 5 to the power of x equals 28? How will we solve those ones there? How do we solve those ones? Our unknown is our exponent, so we would use your log, use what's on your formula sheet there, rearrange them. So it'll be log to the base 3 of 12 equals n. Okay. Where does this come on your formula sheet? Look on your formula sheet where it says logs. The first one there, very start of the video, it has that bx equals y, log b of y equals x. You see that? Yep, we just applied that formula. Now how would I solve this? How would I calculate what n actually is? How do you block them in your calculator? You go log of 12 like the log of 3. Okay? Just like we just did with that evaluate stuff. Okay? So that's what you put in your calculator. That's how you solve for your x. Okay? Rearrange and then do it. So this one here, this would be the log of 5, 28 equals x. What do I put in my calculator? Log 28 divided by the log of 5 equals, what do you do? Chuck that into your calculator. Okay. Now the only other questions that get a little bit harder are where we start to go, well actually let's look at 2 to the power of x plus 3, or let's do a real tricky one, equals 42. Okay, so 2 to the power of 2x plus 3 equals 42. How would you do that one? How could you do that one? Yeah, it's the same thing. This whole part here, this whole part up here, is now exactly where it was before with our x. So it becomes 2x plus 3 equals the log of 42 to the base 2. Happy with that? Now log of 42 to the base 2, that's just a number. What number does that happen to be? 5.36? Is that what I did? 5.39. 39, sorry. Okay, so 39. So now this is just a 2x plus 3 equals 5.39. That's just a linear equation. How do you solve that one? Take 3 off both sides. And then divide both sides by 2. And you're going to get x equals 1.465. Okay. Now it's not 5.
Yeah, I did it wrong.
Sorry, that's wrong. Sorry, Matthew. You would do log of 42 to the base 2 minus 3 divided by 2. So what you do in your calculator is simply log base 2 of 42, which is that there, minus 3, all divided by. Okay, you wouldn't put your answer there. You wouldn't put 5.39 and store it as your actual answer. You'd use your answer button to do it. But that's as hard as log stuff goes. Okay. So we'll do some stuff tomorrow, the next day, which is forming these equations, forming these ones just here.